Hello everyone, welcome back to the video tutorial series of the operating system. I am your instructor Varsha Tak. Let's start our lecture series. So at the end of this video, you will be able to learn about the memory allocation algorithm and then we will see the swapping. So let's see. So here, first of all, we will see the memory allocation algorithm. So what is memory allocation algorithm? There are various algorithms which are implemented by the operating system in order to find out the holes in the linked list, okay, and allocate them to the process. Okay, so in last lecture we have seen the memory, how to manage the free memory. So in which we have seen the two techniques, that is a bitmap and another is the linked list. Okay, so how to find out this free hole in the memory? Okay, and these are the four memory allocations algorithm. That is the first fit, next fit, base fit, and worst fit. Okay, so let's see it one by one. So first of all, first fit. So what is the first fit? Now, as the name suggests, first fit, that means what? The first hole is that will first big enough hole is that will be allocated to the process. Okay, so that is what the first fit. So what is first fit? First fit algorithm, first fit algorithm scans the linked list, and whenever it finds the first big enough hole, it will store that process to that particular hole, and it stops the scanning at the and load the process into that hole. Okay, so first big enough hole the process will find out, then it will stops there, it will allocate the process to that particular hole. This procedure produces the two partitions, which out of them one partitions will be whole while the other partitions will store the process. Two whole will be there, in one partitions the process will be stored and in the another partitions whole will be there. First fit algorithm maintains the linked list according to the increasing order of the starting index. Okay, so first fit algorithm maintain the linked list according to the increasing order of the starting index. Now, this is the simplest to implement among all the algorithm. Why? Because first we have to scan, and if we are able to find the first enough big hole where we are able to load the process, then it is enough that we will load the process to that particular hole. We will not scan the entire list. Got it? It is the fastest algorithm, and because it search as little as possible. Okay, few fastest because it just search a little possible, because with the first big hole, if the process will find out, then that process will be loaded through that particular hole. Memory loss is higher, okay, as very large hole may be selected for the small process. For example, if the 500 kb is there and we just have the process size 10 kb, then that 500 kb hall will be allocated to that 10 kb process. So we have two partition, one is a 10 kb and another is a 490 kb. Got it? Okay, so this is the disadvantage of this. Now let's see this example. So here, example, for the process of 212K, 417K, and 112K and 426K arrives in order. The same example we will follow for each and every type, so you will have the better idea. And this is also the same for each and every process. For example, this free slots is given to you. This will be given in exam to you. Okay, so 100K, 500K, 200K, 300K, and this 600K partition that is given to you. Okay, so here first process is what, 212. Here it is given that it is arrived in order. So first we have to select the 212 only. We cannot select the any other process. You have to select the first process only. Okay, so that is the arrived first. So 212K. For 212K, 100K is not enough. But here the 500K is a big enough hole. So from this 212K, we will from this 500K, we will assign this 212K, and this 288K, that is the free partitions. Now next process is what, 417K. So that we can assign to this 600K partitions, and there is another free partitions. After that, 112K is there. So 112K will be assigned to this 288K because we have the free enough space there. So we will assign that 112K there. This is the first fit. Okay, remember. again the process where CPU will start from search from the first. Okay, so first point it will start from this, it will start searching, and whenever the big enough hole is there, it will allocate the process to that big, that hole. Okay, so here the process of the size 426 will not get the any partitions. Okay, why? Because here you can see there is a no partition that is a big enough that can hold the process, that is a 426. Okay, if we arrange these processes in the proper way, then we will get the partitions. But here in the first bit, we are not able to get the partitions for the this 426K process. So this is also the one of the big disadvantage of the first bit. Okay, why? Because the if the space is there, here you can see the space is there, but still we are not able to allocate the process to that particular hole, because that is not the compact memory compaction is there. Okay, the next is the next bit. Okay, so it works in the same way as the first. No change is that it works as the same way as the first bit, but what is the difference? Okay, except that it keeps the track of the whenever it finds the suitable hole. It keeps the track whenever it finds the suitable hole. From that point only, it will start the searching again. In first bit, it will start the searching again from the first point only. But in next bit, it will start the searching from the last point where it has stopped. Okay, the next time when it calls to find a hole, it start the searching at the it will start the searching the list from the place where it left off last time. Okay, here the search time is smaller. Why? Because it starts from the next where it starts from the bit where it last stops. Okay, so memory manager must have to keep the track of the last allotted hole to the process. So every time it has to keep track about the last allotted hole, because it will start from that point only. Got it? It gives the slightly worse performance than the first bit. Okay, क्योंकि why it gives the worst performance? Because it starts from the it starts from the last bit where it stops in the last. Okay, so that's why it gives the worst performance. Let's see. Same process as I told you, we will follow the same process, and same free allocations we will follow. So here the same partition is given to you. Now here the first process is a 212K. So here you can see the big enough hole is there at what? 500K. So here from this 212K, that will be allocated to the 500K bit block. Now the process will start, now the CPU will start the searching from this point. Okay, after the 212 ends, at this point the CPU will start searching. Okay, so it will start the searching. Now next is what? The 417K. So here you can see the 417K bit is allocated, and after that here 426K. Okay, so that after that, sorry, 112K bit. So 112K bit will be allocated after the 417K bit allocated. Okay, in first bit again it starts searching from the first point. In next bit it will start the searching from the last point where it ends. Okay, so here you can got the you can see the difference in the first bit and the next bit. And again here the process 426K will not get the partitions in this memory location. Got it? So what is the difference between this first bit and next bit? Now, next is the best fit. Okay, so this best fit is the best among all this algorithm. How? Let's see. Entire memory is searched every time. Okay, so entire memory will be searched every time, and whenever it will find the big enough hole, it will compare to each and every available hole. Okay, and whatever the suitable for that particular process, that will be allocated to that particular process. The smallest hole, which is a large enough to hold the process, the smallest hole that will be the large enough to hold the process, that will be selected for the allocation in the past fit. Okay, search time is a high because we have to search the entire partitions for allocating the process every time. Okay, so this is the memory, this is the time consuming process, but it gives the best memory allocation. Its search time is so high as it searched the entire memory time every time. Okay, and memory loss is less in the fast fit. So here see the same processes, same memory space is that. Okay, so in phosphate 212K. So 212K will be allocated to this particular memory space. So we have the less memory loss. After that, again we have the 417K. So 417K bit will be again allocated to the 500K rather than the 600K block in the first pin and next bit that we have seen. Okay, so here you can see this will be allocated to the 500K block, so that is able to hold the process. Okay, so that's why it will selected for this. And here you can see again this is the next this 112K bit, that 112K bit process also get the chance that will be allocated to the 200K partitions. Okay, so again there is a 88K free partition is there, and next process is that 426K. So this 426K again get the chance over here in the best fit. In first fit also we are not able to allocate this 426K. In next fit also we are not able to allocate this 426K bit. But here in the best fit we are able to allocate this process for this partitions. Okay, so this is the best among all the technique, but it required much more CPU time because every time we have to search the entire free partition, and whatever the smallest partition that is able to hold the process, that will be selected for the allocation. Okay, so this is the best fit. Now next is the next fit. Sorry, worst fit. Okay, so what will happen in the worst fit? So entire memory is searched here also. Okay, here we are searching the entire memory. The largest hole, which is the largest enough to hold the process. Largest hole will be selected in the worst fit. Got it? For example, 100K process is that, and we have 5 partitions, that is 100K, 200K, 300K, 400K and 500K. We have 5 partitions. So 100K partitions will hold this 100K process, but still in worst fit it will select the 500K partition. Got it? So this is the meaning of the worst fit. Every time it will select the very big partitions for the process. Here search time is very high because every time we have to search the entire memory location, entire memory partitions that is available, as it search the entire memory every time, and the algorithm can be used only with the dynamic partitions. Okay, this algorithm only we can use for the dynamic partitions. Now here the worst fit, same process that we are taking from the last 3 types of algorithm, and same memory partitions that we have 100K, 500K, 200K, 300K and 600K. Okay, so what will happen? Let's see. First we have the process 212K. Okay, so that will be allocated to the partition 600K because every time it will search the highest big partition. So 212K will be allocated to the 600K partitions. After that 417K partitions. So 417K process will be allocated to this partitions, 500K partitions. Okay, so here the 417K process will be allocated. And after that next is what? 112. So here you can see the 112 can be allocated to this 200K, 300K, but still it will not allocate that process to this partitions. It will select the partitions that we have got from the 600K. And again here we are not able to get the partitions for the 426 K process. So this is also not suitable for the memory allocation. Best fit is suitable for the memory allocation, but again there is a disadvantage. It's required the more CPU time because we have to search entire memory location, entire partitions, and we have to allocate the partitions to that particular process. Okay, and such type of examples can be asked in your example where the process is given you in order and these memory partitions will be given. Here we have the entire all free memory partition, but sometimes in exam also it is given to you some partitions is used. For example, here 200K is used partition may be shown to you in the exam. So such type of examples can be asked in the 7 marks. Okay, so next topic is swapping. Now what is swapping? Till now we are discussing the swapping, that the process will out of the memory and process will in the memory. Okay, so when we don't require the process right now for the execution, so that process will be swapped out, and when any other process that is now needed for the execution, that will process will be swapped in. So this is the concept that is known as the swapping and swap out. So that is known as the swapping. Swapping is the mechanism in which the process can be swapped temporarily out of the main memory or moved from the main memory to the secondary storage and make that memory available to the other process. So this mechanism is known as the swapping. At some later time, the system swap back the process from the secondary storage to the main memory. Okay, so through the performance is usually affected by the swapping the process, but it helps the running multiple and big processes in the parallel, and that's the reason swapping is also known as the techniques for the memory compaction. Okay, performance is little bit slower. Why? Because every time we have to swap out the process and swap in the process. Okay, so every time we have to do this thing, that is known as the context switch also. Okay, so this is happening every time, but it is useful when we are able to when we have to execute the multiple processes at the same time. So this technique is helpful. Okay, so it is also known as the mechanism, or it is also known as the technique for the memory compaction. Okay, so here this is the figure that demonstrates this swapping. Here you can see this operating system partition is there. Here the user space, okay, and the user space where the program is going to be executed, okay, and here you can see if process 1 is a swapped out and process 1 is a swapped in. Okay, so there are numbers of, here just we have shown the two processes, but there are numbers of processes that have that are going to be swapped out and that are going to be swapped in when there is a necessary pages that are stored in the secondary storage that we require for the secondary storage. So the page that are currently in the memory area, they are not in the active state, we don't require that particular page, so that will be swapped out from this main memory. Okay, so for this swapped out and swapping, we will see some algorithms like list return, recently used, first in first out, that every algorithm that we will see later on. Okay, so right now just you know the concept of swapping, that is what is swapping and what is swap out. Okay, so in this video we have learned about the memory allocations algorithm, that is phosphate, next fit, best fit and worst fit. And best fit is the best among all the algorithm, but one of the disadvantages is what we have to search the entire memory partitions, so that's why CPU will be used more, CPU time is more. Okay, and next we have seen the swapping. What is the concept of swapping? We have to swap out the process, we have to swap in the process according to the requirement for the process executions. Okay, so thank you for this lecture. Remaining interesting topic we will cover in the next lecture. Thank you.